foremost I take the constant term and then I multiply it with the coefficient of x squared. In this case it is 1, so that would give me a 4. I place that quantity 4 at the corner of this wedge, and then I observe that the coefficient of x is 5. I retain that coefficient of x over here, and now my next function is to choose two numbers so that the product of those two numbers would give me the number 4 and their sum would give me the number 5. So clearly I know that 4 multiplied with 1 would give me the number 4. Also 4 added up with the quantity 1 would give me the number 5. So having made that discovery, I start off by placing the quantity x squared followed by the quantity 1x and then 4x followed by the constant 4. Now this is my group 1 and this is my group 2. From group 1 I would be taking x as a factor. X multiplied with x would give us x squared, x multiplied with 1 would give us 1x, followed by the positive sign. So from group 2 I would be picking out the number 4 and that would leave me with x positive 1. So clearly x positive 1 can be taken out. One of the x positive ones can be chosen as a factor and that would give us x positive 4. So this is our solution. So for question number D, the solution is as follows. Foremost we multiply 20 with the coefficient of x squared, that is 1 in this case, and that would give us the number 20, and the coefficient of x in this case is negative 9. So I need to choose two quantities of numbers whose product would give me the number 20 and whose sum would give me the number negative 9. So obviously that would be 5 and 4. Clearly 5 times 4 gives me positive 20, but 5 added up with 4 would give me a positive 9. So the only way we could obtain a negative 9 is to have a negative sign. So hence the given question can now be rewritten as x squared followed by a negative 4x and a negative 5x. Of course the constant term has to be placed. So this is my component 1 and this is my component 2. From component 1 I am picking out x to be the factor, which would in turn give me x negative 4, and then retaining this negative sign, and I would be now taking 5 as a factor, and that would give me x as a first component and negative 4 as my second component, because negative 5 times negative 4 would give me positive 20. So clearly x negative 4 can be taken out as a factor and that would leave me with x negative 5, hence the solution.